Okay, so this is what our diagram for that question should look like. Okay, and then our resultant, you could draw the triangle this way, or you could draw it inside as well. It's totally up to you. Okay, that'll represent the displacement of the elk. What does the question want? It's velocity. It does give you the times for each section, so there may be an additional calculation at the end of this that you have to do. Okay, so that's what your diagram, vector diagram, should look like for this question. I'll give you a few more minutes to get ahead of me on calculating all the x's and y's and all of that good stuff. Okay, let's have a look at some of the calculations here. We'll start with the red triangle. Okay, so to get red x, red is opposite my 25-degree angle, so I'll use the sine of 25 times the hypotenuse, 800, to get x, to get red x. Okay, so sine of 25 times 800. All right, so that side is going to be 338.09 meters, and that is west. Okay, and then the y component, okay, that is going to be the cos of 25 times the hypotenuse, 800. That side will be 725.05 meters, and that's north. Okay, for our blue triangle, x is adjacent to the 15-degree angle this time. So cos of 15 times the hypotenuse, which for the blue triangle is 1,200 meters. That side's going to be 1,159.11 meters east. Okay, and our y component is the opposite side this time, so we'll have the sine of 15 times the hypotenuse, 1,200, okay, and that side's going to be 310.58 meters. South. All right, so now that I've got all of those, now I can get my resultants triangle. Okay, so that is going to be purple x and purple y. All right, my x components, one of them goes west, the other goes east. Okay, so they are opposite, so when I put them together, I am going to make east positive, okay, and I'm going to make west negative, because that's usually the way that it goes. So I will take my 1159 and my 338. Okay, plus negative 338. Or you could just minus, it's either one. Okay, so in the end, the elk ends up 821.02 meters east. 2 meters east. Okay, so that's that one there, 821.02 meters. That's pointing east. All right, both y components are also opposite. Okay, in the red triangle, the y component is north. In the blue triangle, the y component is south. So we'll have to do the same thing with them. That'll be my 725 and my 310. Okay, so okay, so we end up 414.46 meters north. Okay, 414.46. So my triangle ended up okay. It's not perfectly to scale, but it's at least representing what happened. Okay. So now that I've got that, what's my next step?
Triangle.
Right, the Greek key, Pythagoras, that guy. Okay, so now I want to find out what is the magnitude of the elk's displacement. All right, so that means d will be the square root of the two sides. So 821 squared plus 414 squared. Okay, so root of 414 squared plus 821 squared Okay, so the overall displacement's magnitude is 919.70 effectively here, right? We'll say 69. Well, I'm going to just write 70, 919 meters. Okay, so I've got the magnitude. Now I also need the angle, right? To get that angle, opposite over adjacent for me. So I'll go tan theta will equal 10 to the minus 1 of the 414, opposite divided by the adjacent, 821. Obviously with all the decimals in my calculator. Okay, so I'm looking at 26.79 degrees. Okay, and for me, what direction would that be? North of east, right? It's the angle arc there is touching east, so it's from east or of east, north of east. Okay, still have work to do. Question wants the velocity. Of course, I need the displacement in order to do that part. Now I have it. So I've got the two times are 49 seconds and 63 seconds. Okay, so time, do I need my total time for this if I want to find average velocity over the whole trip? Okay, so 49 seconds plus 63 seconds. Okay, so 49 plus 63. There's my total. Oh, not times. 49 plus 63. Okay, it's giving us 112 seconds. Okay, so now we have our total time. Okay, average velocity equals total displacement, which I have, and now I also have the total time. Okay, punching in those numbers. Okay, we've got 919.70 meters at 26.79 degrees north of east, divided by 112 seconds. Now, did you have to write all of this in your calculations? No, I do simply because I want to remember to carry it over. My velocity has the same vector as my displacement, always. Okay? All right, so I'm going to take that 919 with all the decimals, divided by the total time. Okay, so average velocity of the elk, 8.21 meters per second, okay, at that vector. But now I need to go back and check something. What am I going back and checking? Significant digits. Okay, 3, 2, 3, 4, 2, 3. What's my 2? Okay, 2 is the lowest number. I use those times. Okay, sorry, I use the degrees, sorry, not the times. Okay, I use the degrees to calculate everything. So my final answer, okay, is going to be that the average velocity is 8.2 meters per second at 27 degrees north of east, or 63 degrees east of 3. Okay, east of, I would accept either one of those. Okay, is that a long, involved question? Would it give you like that on a test, like a unit exam? No. Okay, you have to do a lot of other things on a unit exam. You can't spend the amount of time a question like this takes on a unit exam doing a question like this, which only demonstrates to me that you know how to calculate vector components, you know how to draw a diagram tail to head, and you know how to do vector component addition. I can test that with a much shorter question. And the other thing this calculates, can you do V equals D over T? Well, I'm going to test that in a whole bunch of different ways. I don't need to make it part of a question like this. Okay? Why do we do a question like this? It's a good exercise in practicing all those little parts that we need to know how to do. Okay? And that worksheet that I gave you on Monday, okay, that's what we're going to work on today. Right? There's a couple of questions on there that are really, really long. There's one about Indiana Jones carrying the golden idol and avoiding all of the different booby traps and stuff. We actually go back to that example like in 3 different situations in this course. Okay. So we're going to look at that, okay, and you know, it's like a 5 vector component question, okay? Does that make it hard? No. It makes it tedious. Yes, that it does. All right. How are we feeling about this stuff? Right? I mean, once we learn the method, it's just doing the steps every time. If we remember the steps are always the same. Right? Just punching it in your calculator and putting them together. All right. From that sheet. Okay, question number 3 on that sheet. I would like you guys to do 3 C and D. Those are both exam level, where one is straight along a compass direction and one is angled. Okay, and I would like you to do F, just because that's a trickier diagram, and I want you to be able to practice trickier diagrams. Okay, so let's start with those 3 for right now. Okay, and then we'll go through them together here, one at a time in a few minutes. All right, so for C, we've got 8 meters east. Okay, and then we've got 6 meters at 35 degrees northeast. So reference line east, 35 degrees, 6.0 meters, something along those lines I think is going to be reasonable for scale, X and Y. Okay, and then our diagram's resultant should go like that. Okay, you could draw the triangle this way or this way. I think the one they did is the way I drew it, because they've got east of north there for their final vector. So Y, X, and overall displacement. Okay, finding our X's and Y's. For the purple line, that's pretty easy. X is 8 meters east. Y is 0, because it only goes east. Okay, and then for our green triangle, we do have to do a little bit of trig for that one. Okay, green X will be the cos of 35 degrees times 6 meters, and Y will be the sine of 35 degrees times 6.0 meters. Okay, so 4.915 meters east, and then for Y, sine of 35, whoop, not cos, already did cosine of 35 times 6, 3.441 meters north. Okay, now that we've got those, we can find red X and red Y. Red Y is easy because we only have one Y component, so it'll be 3.441 meters north. And X is just going to be adding 8 and green X together, so that will be 12.915 meters east. Okay, then we can do the Pythagoras and the trig for that one. Okay, so take that 4.91 and add it to 8. Sorry, just so that we have it as an actual number with all the decimals. Okay, and then we'll go square root of that number squared plus that number squared. Okay, our Y component. Okay, so we got 13.366 meters. Okay, and then we just have to find the angle. So second tan of the opposite side. For me, that was the 12. Okay, divided by the adjacent side. Okay, the 3.44. Okay, we're looking at 75 degrees, which is exactly what the answer said. 75 degrees, and for me, that's east of north, but I would also accept 15 degrees north of east. Okay, final answer can only have 2 significant digits, so we're looking at 13 meters, 75 or 15 degrees. All right, questions on C? How many people have done D? Okay, I'll give you a few more minutes, and we'll go over D. Okay, so looking at D here, guys, we got 12 meters south. This one's often tricky for people because of scale, right? So 12 meters, right, 12, not 11, 12 meters south, okay? And then 15 meters at 55 degrees east of north. Is that more than halfway from north to east? It is, because halfway would be 45 degrees. So this is a big angle, and the mistake people make here is exactly what I said, it's scale. So here's north. 55 degrees east of north looks like this, okay? And even if I draw that to scale, like my 12 meter line is shorter than this line, and it should be, because this line's 15 meters long. But it doesn't get up here. It doesn't get past where I started, okay, from a north-south perspective. But what a lot of people do is they draw it too long and they end up way up here somewhere, okay? This is just another example of, hey, let's practice drawing trickier diagrams where scale matters. All right, so this angle here will be 55 degrees. So I drew too much blue line here, but okay. And then this will be X, and this will be Y, and then we've got 15 meters there. Okay, so we're looking at something like that. Maybe I could have drawn that 15. You know what? I'm going to draw just a little bit longer because I can. Probably should be just a hair longer. Do that. Okay, so here's X, there's Y, okay, and our 15 meters. So that means that my resultant is going to look like this. Okay, I'll draw the triangle this way, but if you draw it the other way, that's totally fine too. Okay, I think they actually drew it this way for the answer there. So X and Y for the green, and this will be our overall displacement right here. Okay, so if we're looking at our X and Y components, red X is 0 because it goes due south, 12 meters. Okay, so red X is easy. I don't have to do any trig for that. It's a straight vertical line. All right, then for our blue triangle, okay, blue X is opposite the 15-degree angle. Okay, so that'll be the sine of 55 times 15 meters, and Y is adjacent, so it'll be the cos of 55 times 15 meters. All right, so sine of 55 times 15 meters gives me 12.287 meters, and that is east. Okay, and then for my cos of 55, times 15 meters, okay, I'm getting 8.6 meters, 8.60 meters. 604 meters, and that one is south. Okay, so if I'm finding my resultant, the green triangle, okay, I already know what green X is because it only goes east 12.287. I don't have to do any figuring for that one, but I do have to do the figuring for green Y, right? So green Y is going to be the 12 meters south, okay, which I'm going to say is negative, right, plus the 8.604 that we're north. Okay, so I'll take 12, and negative 12. Negative 12, and I will add to that the 8.6. So I still end up south. That's why I add a negative. That way when I do this, I know, okay, south's negative, I got a negative number, okay, so I ended up south of where I started. All right, so 3.396. 3.396, put all the numbers in, 396 meters, okay, and that is south. All right, now that I've got those, okay, now I can find out what my magnitude of my displacement is. So that'll be 3.396 squared plus the 12.87 squared, 12.287 squared. out this time. Okay. Not that that should be. Squared plus this time thing may be 12 squared. Whew. All right, that seemed like a lot of work to get that number. 12.748. Okay, so this is 12.748 meters. Okay, and then we got to find theta. The way I drew the triangle, y is opposite, x is adjacent. Okay, so I just go second 10 of the 3, take the negative out of there, okay, and I divide that by the 12. Okay, so I'm looking at 15.45 degrees. And for me, that's south of east. Okay, so in the end, we can only have two significant digits. 12.7 rounds to 13 meters. And then 15.45 stays at 15 degrees south of east. If you drew the triangle the other way, then you got 75 degrees east of south. All right? Everybody with me there? Okay. Diagram a little misleading. It can be, or sometimes you can draw it in a misleading way. Okay. And of course, that's just the point of it. I know you guys can do all this trig and Pythagoras. I know that's not the issue. Okay, it's practicing the scale for sure. All right, how many people are done F? Okay, let's look at F as well then. Okay, so on F we've got 9 meters, 35 degrees north of east. All right, so we'll go east, and we'll go 35 degrees north of that. Okay. 9.0 meters. There's X, there's Y. Okay, and then we're going to go 7 meters, 25 degrees south of east. Okay, so scale's important here, not as important as the last one, because obviously this second line is shorter than this one, and the angle isn't as steep, so it's definitely not getting down in this area. Okay, it's going to be more in this area here. 7.0 meters, okay, and it's 25 degrees south of east, so this will be X, this will be Y, okay, and then our resultant will go like that. Okay, so X, Y, overall displacement, and theta. Okay, so diagram should look something along those lines, you know, at least again, reasonably to scale. None of my angles are crazy or anything like that. Then we got to find all of our X's and Y's. Okay, so for the green triangle, okay, X will be the cos of 35, and the hypotenuse of the green triangle is 9. Y will be the sine of 35, and the hypotenuse is 9. Cos 35 times 9, okay, 7.372 meters east. Okay, and then for Y, sine of 35 times 9, okay, looking at 5.162 meters north. Okay, and then for our red triangle, okay, red X is the cos of 25 times 7. Okay, and Y will be the sine of 25 times 7. Okay, so 6.344 meters east. And for the Y component, it's going to be south. Sine of 25 times 7 will be 2.958 meters south. All right, so I only have to watch my y components. One's north and one's south. The x components both go east, so I can just add them together. Okay, so to get my purple x, okay, purple x is just going to be 6.344 plus 7.372 because they both go the same direction as we said just a second ago. All right, so 7.372 plus the 6.344. All right, so we go 13.717. meters east. Okay, and y will be north. So I'm going to take that 5.162. And I'm going to add to it negative 2.958. I get a positive number, so I still wind up going north 2.204 meters. Okay, now I can do my Pythagorean theorem. Okay, so that'll be the 2.2 squared plus the 13.7 squared. Okay, so my overall displacement's 13.892 meters. Theta, the way I drew this, opposite is y, adjacent is x. So tan to the minus 1, 2.2 divided by the 13.7. Okay, so I'm getting 9.128 degrees, and for me that's north of east. So my triangle's probably a little bit off. I probably could have made the 7 meters a little longer, okay, or maybe I made the 35 too steep or something along those lines. Okay, and now I've got to put it in the right number of significant digits. Everything's got 2, so I'm going to be looking at 14 meters at 9 degrees, actually 9.1 degrees north of east. Here's a little trick though. That number's got 2 significant digits, right? So does the other acceptable answer. But it's not as accurate, is it? Every once in a while that's going to happen. It's pretty rare. But yeah. All right. Questions on those? Okay, I'm going to give you a 5-minute break there. We'll do one tricky. Involved one. Boat questions. We haven't done boat questions last week. All right, you got 5 minutes within the classroom here, guys. Okay, so question number 12 is a boat question from that worksheet. Okay, want you guys to try this one. First decision you have to make, is this a rowing across or a going across question? Okay, and then solve it from there. Remember, going across means you end up straight across. Rowing across means you're rowing straight across, but you don't end up straight across. You end up downstream. So a little reminder of the 2 times. It may be that this may be right or wrong. I have to have a look at it because I don't know if I used the rounded value. Ryan was pointing out that I may not have used the rounded value here. Okay, we'll double check that. Okay, so a boat that can travel 4 meters per second on still water. That's telling you that's how fast you can row this boat. Okay, regardless of what else is going on, that's how fast you can row. Okay, and it's rowing it directly across the river. So is this a rowing across or a going across? It's a rowing across. Okay, otherwise they would say the person wants to end up going across, or that would tell you that they're pointed some angle upstream. It does not say that. It says that you have pointed the boat that you are rowing this way. And that's the way you're rowing it. It is not the way you are going it. Okay, it's going to end up going downstream. So 4.0 meters per second. Okay, we also know that the river current is 2.1 meters per second east. So I'm going to put that on here, slightly more than half as long as my rowing line. Okay, and the river is 125 meters wide. Okay, so that's this direction, 125 meters. Okay, so what's the velocity with respect to the shore? Well, I would say this is the shore here. Okay, so our velocity would be this line, but it wants this angle. Everybody okay with that? Can I just flip my triangle over to do this in one step and just, I'll get the same numbers, right? I can just go, this side's 2.1 and this side's 4.0, and then I don't have to go 90 minus, or I can do it that way and go 90 minus, whatever works. Okay, so first thing I'm going to do is get the velocity. I'm going to get the magnitude of the velocity. That's just going to be a Pythagorean theorem calculation, because this is just perpendicular vectors. So 2.1 squared plus 4 squared. Okay, and when I punch that in, that should give me 4.5. So. Okay, so 4.51. We only have two significant digits here, so 4.5 meters per second. Okay, I also need the angle measured from this shore. So 10 to the minus 1, that makes the opposite side 4, and the adjacent side 2.1 to get me the angle I'm actually looking for directly. So second 10 of 4 divided by 2.1 is going to give me 62.3 degrees, okay? And that will be actually two significant digits, 62 degrees. Now, the answer doesn't say that. What does that say about the answer? That's wrong. That is not with reference to the shore. That's reference to compass directions, which, I mean, that's fine. They gave me north and east. That's a relevant vector. But if the question specifies which direction it wants it from, I'd better give that direction. This is a poorly worded question, so I would have to accept both. Okay, but we would want to make sure that we get, okay, on this one 62 degrees, and it would be north of east, or I would accept north of the starting shore, or from the shore would even be good enough there. That's what it asked for. Okay, so 62 degrees would be our correct answer there. Okay, for B, how long does it take the boat to reach the opposite shore? Well, to get that number, I have to use numbers that point the same direction. If I'm going to find a time, okay, I need to use a D and a V that go the same way. I cannot use this number here that I just calculated, because that doesn't point across the river. I don't know how far I would go along this vector, because I never calculated that. But I do know I'm going this way at 4, and that's 125 meters. So 125 meters divided by 4 meters per second will give me how long it takes to get across the river. That's the part on these questions that people mess up the most. Okay, is they use the wrong velocity to figure out how long it takes to go across. Okay, yeah, does this get me across? It does, but that's way further than 125 meters. Okay, all right, so I would use on here then 125 divided by 4, and that is going to give me 31.25 seconds. Okay, I only have two significant digits, so I'm going to knock that part off, and my total time is 31 seconds. Now, here's the thing that Ryan pointed out to me. He said, we're supposed to use the rounded value from B to calculate C, and he's absolutely right. Okay, that's one of the rules of significant digits. If I need to use something I calculate in B to solve for C, I use the rounded value. I don't want to keep adding on things that are not accurate if I'm not certain of them. So that I'm certain of. Okay, so to figure out how far downstream I end up, I'm going to take D equals B times D. 2.1 times 31. Okay, should be 65, not 66.
The angel of the Lord